We're going to be looking at how to use Desmos to help with graphing the statistics. So we're going to start in 10.1.3, looking at the procedures on 10.43, so problem number 43, and how to graph those in Desmos. Now, one of the great things about Desmos is that you can copy-paste data that's in a list. And so we're going to create those procedures over here, and we're going to copy that list. So we're going to make a set, and in order to do that, you type in a capital letter. So in this case, I'm going to type in a C because I'm using two different procedures, C2 and C7, and then I want to designate it to be C2. And so I'm just going to type in a 2, and when I do that, Desmos automatically makes a subscript or a number below the C. And then I'm just going to put an equal sign, and then I'm going to put a hard bracket, so a square bracket in, and then I'm going to copy and paste the procedure numbers, the data set. So I'm going to copy it, and then I'm going to paste it inside my square brackets. And then I'm going to do the same for C7. So capital, I need to do a capital, otherwise Desmos will think it's going to be a slider. And then C7 is equal to square bracket, and then I'm going to copy paste again. So now that I have my two procedures, all of the data in there, Desmos is going to allow me to do some graphing. So if I wanted to graph a box plot, I just type in boxplot, not capitalized, and then a parenthesis, so not a square bracket, but a parenthesis, and then the data set that I want to use. So it says enter the data set. So I'm going to put in C2 first. And I can see my box plot appear. If you can't see your box plot appear, it's likely that your data is very large. So in this case, I can see my data is 7, 6, so all of those numbers are going to show up over here. So I can see my data in there, not quite to the end, because it looks like my highest data point is 29. In order to change that, I just go over here to the wrench and click it. And I can show on my x-axis, I want to see how far it's going to go, and it depends on what my largest number and my smallest number is. So it's at 4 over here, so I think I'm actually at a good place right here. But I do want to go all the way, like maybe 32 or so, just to show the end. So 32, 33, and then I can see the end of my box plot here. Now I'm going to go ahead and graph the other box plot for C7. So same procedure, C7. Okay, now I see those box plots are sort of on each other right there, and I can move them, I can offset them. So I'm going to go ahead and put this at 10, and then maybe this slightly below it at 8. And then if I change the height, it just actually increases the box more. So if I wanted to change the height, I could, but I don't really need to. It's pretty visible like this. And now if I want to create a histogram, I just type in histogram and do the same thing. So there's my histogram, and that histogram is for C2, so I'm just going to go ahead and change the color there to match. And I do that just by clicking and holding down over here. And then I'm going to go ahead and create a histogram for C7. Okay, and I'm going to go ahead and change that to purple. Okay, so I can compare now by using a boxplot histogram combination. And if I want things to disappear, I just kind of click over here so I could look at this one first. And it's kind of hard to see because this one doesn't do the modified box plot with the outliers. You don't need to know how to calculate outliers in this course, but you do need to be able to see them. So one way we can see them, if you look at our purple right here, you can't really, it looks like there's not a whole lot of outliers, but something's going on here. And so we can look at the dot plot. That helps us determine some of the outliers. So I just type in dot plot. And then C3. Oh no, C2. And then I can see that these are probably my outliers, probably these two, maybe even this one right here. These ones all are showing up. So it just creates that dot plot so I can see exactly where those outliers might be. And then some other things that Desmos can do to be helpful is it can calculate your quartiles as well. So instead of just trying to eyeball where this is, you can type in quartile. And we want the quartile for, let's say, C2. And we want quartile 1. So it'll give the number right here, this 4.5 is where the quartile is for C1. So we can see that right here. And then if we want the third quartile, we can calculate that as well. And then we can even use that to calculate the IQR, or interquartile range. If we just take this one right here, quartile 3, and we subtract quartile 1, we could do this all with numbers as well, but just type it in, and then we get our IQR. Now, why we would want to use the IQR to determine our spread here instead of using standard deviation is because we've got these outliers over here in C2 that's really pulling it along. So we want to use the, and the mean would give you kind of a not super reliable estimate of measure of center. So we want to use the median, in which case then we want to use the IQR to determine our spread. And so we can also type in median if we want to compare these two procedures. So medium C2. So our median for C2 is 6. So that's our middle number for C2 for this procedure. So 6, and it's 6 minutes. So that's from the time when 911 was called to when the paramedics reported the bleeding stopped. So our procedure of C2 has a median of 6 minutes. However, it's also got these outliers over here. So even though it's got kind of a small median, but let's look at the median of C7. So that has a much larger median. However, if we take a look at the graph for C7, we can see that it's very likely that will happen around that median. We don't have so many outliers. So an interesting thing to think about when you're deciding which procedure is better. It can't just be based on the median. Also want to take a look at some of the outliers and the spread as well. So that's how you use Desmos. Oh, another thing with the histogram, our book has it centered left. So this is what all of your histograms will look like. And what that means is if there's a value in between here and it's on the edge, so if you had a value of 15, it actually wouldn't be in this bin, it would be in the next bin. And when we talk about bins, you can see where it says bin width right here, and it gives us sort of some guidelines on how big we want the bin width to be. And the bin width here, it says what you might want to do is take a look at the number of data points and then take the square root. So in this case, 2, 4, 6, 8, 10, 12, 14, 16, 18, about 20. So about 20, so between 4 and taking the square root of 20, it's going to be between 4 and 5. So maybe we want our bin width to be about 4. And that's just convention. And we probably want the bin widths to be the same if we're going to compare them. And we still see that our purple is our purple one, or C7, is much more symmetrical than our green C2 when we're looking at those histograms. And now that we've changed that, we probably want to move our box plots up a little bit. So maybe to 14 and maybe to 11. So that just moves them up so we can see them a little bit more. And that left center, we can see if it's right on the edge here, if it landed here at 16, we would put it in this bin. That's all that left means. It's just convention. And the way that our book does, it does it as left center. So you can use Desmos to do all kinds of things. There are other statistical things you can do with Desmos. It's pretty powerful. It's very nice to have when you're doing this. You can even use it to calculate standard deviation once we get to that. So here are just some of the statistics that it supports. So Desmos is a pretty powerful technology tool to help you check your answers and to help you graph things and compare those graphs with each other.